Okay, today we are going to add radicals. Okay, you can add radicals by combining like terms. Radical expressions are like terms if they have the same radicand. Okay, and if you recall, the radicand is the number inside the radical. So in this case, the radicand would be x. So look at the first example. These are all radical expressions, radical terms. If they have the same radicand, they can be combined. So if I look at the radicand here, it's 5. This is also root 5, which means these are like terms. So if I have 3 square root 5s plus 4 square root 5s, I have 7 square root 5s. I'm just adding up the number of square root 5s I have. I am not changing the radicand because I'm not multiplying. Okay, let's go ahead and look at B. It's 11 root 3 plus 2 root 7 minus 5 root 3. Okay, the first radicand is the 3, the root 3. Let me see. This is root 7. Here's another root 3. So those are my like terms right there, the ones that have the root 3s. So I have 11 root 3s minus 5 root 3s, which is going to give me 6 root 3s. Okay, what else do I have? I have this plus 2 root 7, which I'm still going to bring down because it's part of the expression, but it's not a like term, so I can't combine it. So my final answer is 6 square root 3 plus 2 square root 7 because they're two different radicals. Okay, let's go ahead and look at 6. Let me look at the first term. 11 is rational. It doesn't even have a radicand. So let's see if there's any other terms that don't have a radical. Square root 11, 4 square root 11. There's a plus 5 at the end. So I can do 11 plus 5 since they're both rational. I'm going to get 16. Okay, now let's check. Now I have a square root 11 minus 4 square root 11. Okay, those are like terms because they have the same radicands. They're both square root 11. So I have positive 1 square root 11 minus 4 square root 11. So 1 minus 4, I'm going to have negative 3 square root 11s. So my final answer is 16 minus 3 root 11, and the order doesn't matter, so I could also have negative 3 root 11 plus 16. Okay, let me check here. Okay, let me see. This is 7 square root 2, and this is square root 18. Their radicands do not match, so they seem like they're not like terms. However, if I look at the square root of 18, I can simplify that because if I think about square root of 18, that's the same as the square root of 9 times the square root of 2. Square root of 9 is 3, and the square root of 2 I don't know. So now that I've simplified it, let me bring down the first term, and now look at them. Okay, now I have 7 square root 2 plus 3 square root 2. Since they have the same radicand, I can combine them now. 7 square root 2's plus 3 square root 2's means I now have 10 square root 2's. Okay, let's look at the next one. For E, let's see, I have square root 125 and square root 20. They definitely are not matching radicands. They are not like terms, but they don't appear to be. Let me see if I can simplify either of them. Let's see, 125, that sounds like quarters. So I could do 25 times, how many quarters are in 125? 5. 25 times 5 is 125. I picked 25 because the square root of 25 is 5. So I got 5 square root 5 minus, that still doesn't match root 20. So let me look at the square root of 20. I could do 2 times 10, 4 times 5. I'm going to do 4 times 5 because 4 is a perfect square. Square root of 4 is 2. Square root 5. Okay, now I have 5 square root 5 minus 2 square root 5, which are like terms. 5 square root 5 minus 2 square root 5 is 3 square root 5. Okay, let's look at the next one. I have square root 44 plus square root 99 minus 5 square root 11. Okay, right now none of the radicands match. So let me see if I can simplify anything. Okay, 44 is 4 times 11, and the square root of 4 is 2. So I can simplify square root of 44. What about 99? That's 9 times 11. The square root of 9 is 3. Now 5 square root 11, actually that already has a radicand of 11, so I'm going to leave it the way it is. Okay, if I have 2 square root 11 plus 3 square root 11, I have 5 square root 11s, and if I subtract 5 square root 11s, I have 0 square root 11s, which means I have nothing. So my final answer after all that work is 0. Let's try a couple more. Okay, let's see. We have 11 square root 45. We have minus 6 square root 5. We have 7 square root 20. They all have different radicans. So let me see if I can simplify. Okay, 45 is 9 times 5. Okay, so that's 3 square root 5. But don't forget there is 11 in front of the radical. So that's 11 times 3 square root 5, which is really 33 square root 5. Okay, now let's look at the next term. Okay, I have minus 6 square root 5. Actually, I really like that now because now I have a matching radicand. So that's a good sign. Okay, now let's look at the root 20. Square root of 20, let me do 4 times 5. So that's minus 7. The square root of 4 is 2. Square root 5, and remember I'm multiplying the 7 times the 2, so this is minus 14 square root 5s. And now everything is a square root 5, so I can combine them. 33 square root 5s minus 6 square root 5s is 27 square root 5s. And then if I subtract 14, now I have 13 square root 5s. Okay, let's look at the last one. I have 7 square root 2, positive square root 6, square root 50, and square root 54. And again, nothing matches. Okay, now 2 is 2 times 1. I can't do anything with that. Let me consider 6. I could do 3 times 2, but neither of those are perfect squares, so that's not helpful either. Let's try 50. 50 cents is 25 times 2. Okay, so I'm going to go ahead and make that 5 root 2. Let's bring down those other ones since I couldn't do anything with them. Okay, I at least now see square root 2's matching. Let's try 54. That's going to be 9 times 6. So that'll be 3 square root 6. Now, do I have like terms? I have 7 square root 2's plus 5 square root 2. So I have 12 square root 2's. Okay, now I have square root 6 plus 3 square root 6. Remember, this is 1 square root 6. So 1 square root 6 plus 3 square root 6's, I have positive 4 square root 6's. I cannot combine these together, but I simplified as much as I could. Okay, go ahead and try the practice problems. When you're done, you can check the calendar to see if your solutions are correct.